Alrighty, CNT140, Chapter 5, we're talking about some fiber optic testing. Now, we're going to introduce a bunch of these. Later this semester, we're actually going to do a bunch of these tests and checks on fiber and fiber connections. So we're going to lay some groundwork now. We're going to revisit some of this later. Alright, so after termination and or getting fiber, I need to do a couple tests on. They talk about visual inspection, loss, and polarization. So the first one, visual inspection, I need to look at the end of the connector to know if I did any polishing on it, if it's polished well, if there's any dirt, is there any debris on, and that is going to be done with your fiber optic microscope, this guy right here. Now, caution, this needs to be connected to a fiber that is not, there is no light source on the other end. So this cable needs to be not connected to anything if you do this. If there were a light source coming through here and it gets magnified, it can do damage to your eye. So we need to make sure this is not a live connection. I'm putting that out there first. Now, what this is going to allow me to do, the connector comes in here. There is actually a microscope in here that allows me to look at the end of that connector under magnification to see if there's issues with, is there any dirt and scratches on. These are obviously scratches. Here's some dirt up here. That's going to cause issues with the signal going through the cable. If there is a lot of dirt, here's some picture with some dirt around the end of the fiber. Oh, and by the way, as I look at these here, I can see the core and the cladding in there. See the core and the cladding in there. That's what I'm seeing. And the ceramic ferrule around the outside. Here is a bunch of oily residue, actually almost like little oily drops there. And then here will be a smudge from a finger. Your finger actually has natural oils on, so if I run my finger across, I might leave that kind of debris up across the end of the connector. So with my fiber, I need to look for that, and we'll talk a little bit about cleaning the fiber. We'll talk a little bit, in just a little bit here, we'll talk about cleaning the fiber. The next one I need to worry about is a loss, insertion loss test. So now I actually need equipment where I have a light source, actually a light source here, sending light through the fiber, and this over here is able to measure how much signal loss. Again, think of this as looking at water moving through a garden hose. You know, if I hook it to a faucet and I turn the faucet on and a lot of water comes out the other end, it's like, hey, looks like my hose is doing all right. If I turn the faucet on and I look at the water come out the other end of the hose and there's almost no water coming out, I'm going to start looking at the hose thinking there's a hole in the side and the water's squirting out. And sure enough, I go down, oh, yep, there's a hole in the side and water's squirting out the side. So this is the same idea. I'm going to put a light source on here and I'm going to measure it out here, and there's going to be a little loss, but this should not be a lot. So with that, I'm actually going to use this meter. We'll use this later this semester to measure the amount of loss through that cable. And some can be through the connection, through the connectors on each end. Some can be through the fiber itself. Last but not least was polarization. I need to make sure the polarity is connected right. So here, I have a reminder that typically my connection for fiber, I need it to literally flip over at some point so that the transmitter on one end is actually connecting the receiver on the other. So I might need to make sure that my polarity is right. Well, in an installed cable plant, typically the fiber installed in the walls and all has that already flipped. So I can use a straight through patch cable on this end and a straight through patch cable on this end to make connections. The installed plant is usually the part that has the crossover built in. But if that didn't get done for some reason, I might have a connectivity issue. They talk about fiber testing a little bit simpler than copper because it's really just those loss things. I'm looking at loss, and I'm going to do some basic tests to do that. I would have a light source, and I'm measuring this over here. I start with a reference, then hook my cable up and be like, oh, okay, there's that much loss in. And that's really what I'm looking for. And as long as it's within value, it's a usable connection. They are sensitive to dirt and contamination. So they remind us about cleaning the connector, also using dust caps when a connection is not in use, whether it be across the end of the cable or across the port. I need to have dust caps on things because we don't want it, dirt from the connector going in the port and vice versa. So before making any connections, we use a fiber optic cleaner. This is the style we have in the lab room. That's the picture I used. I actually press that down. This little sleeve slides back, and there is a no lint cloth there that I'm going to use to clear the end of my connector. They also make ones that are one click that I can use to clean the end of a connector or an actual device port. As I click that, the little media on the end kind of rolls around the end and back into the tube, so it kind of like swipes the dirt away, if you will. Again, we talk about testing optical loss. Okay, they talk about absolute, relative, that sort of thing. The difference between those is the actual loss. So the absolute coming out and the actual measured, I compare the two and be like, well, that's how much loss there is. And it's usually measured in decibels, and I'm usually going to see a negative decibel number. And as long as that number is not too great, my connection is good. This is the kind of equipment you'll be using. Ours is similar to this guy over here. And then I need to make sure, according to my standards, is it within value? Is it within value or exceeding too much? And again, that's the kind of power meter equipment that I'm using. And I think here I have, standard cable loss. I launch light in, I'm measuring the other end, I'm testing. And again, I need to maybe use different wavelengths for different fiber. And I need to make sure it's less than the rated amount. I even show you some different pictures here of ways, according to patch cable testing and installed cable testing, what I would do, how I would connect those up and do them. Here is showing some loss. This was from one of the tables in our book, but according to our standard, this is the amount of insertion loss that's allowed. So as long as I'm keeping it below that, I know that I'm okay. I know that I'm okay for my connection. One of the last tests they mentioned for us is OTDR. So with copper cabling, we have TDR, time domain reflectometry. With optical fiber, I have optical time domain reflectometry. So this is actually going to allow me to measure distances of cable and look for any potential sources of loss. So if I test that, and this is, I think, a picture they had in the book, anytime I have a termination, this might be a termination on this end, termination on the other end, or partway through, maybe at the patch panel in the middle, and termination at the other end, I'm going to have little blips in my chart, if you will. But any other areas that I'm seeing might be some source of splice or any kind of issue that might be causing my loss. And this is the kind of graphs that you would be getting, showing me my terminations at different points. And these should be like, okay, yeah, that's that patch panel. Oh yeah, that's that termination. But if I start seeing other ones in there, that might be the cause of my problem. There might be the fiber was bent too tight and there's actually little microfractures and some light is leaving the fiber at that point. And that might be a part I need to track down. Which leads us to, the book doesn't talk about this, but I do. There is a visual fault locator that can be used. The visual fault locator actually just overfills the fiber. The light source here overfills the fiber. And if I don't have any problem with the fiber, the light kind of spills out the other end, just kind of like squirting out the garden hose. But if there is a problem in the fiber, microfractures, this just lights it up. And it literally, the light just kind of like bleeds out through the jacket, if you will. That's why I said it totally overfills it. And that'll let you know, oh, that's where my fractures are. I might need to replace this cable. We have one of these and we'll use later this semester to show you problem cable. Locate a problem in a problem cable. There we go. There's our fiber optic chapter with a really good foundation of a lot of things that we will be working with and or talking about or building on later this semester.